Okay, this time let's have a look at some of the bugs that we have in our application. So on the server side, the most obvious bug is that we actually crash whenever a user disconnects, which, as you can imagine, is less than ideal. So how could we address that? Well, look, let's start by doing a little refactoring. So I'm just going to move the sender task down there, and I'm going to make a new task. I'm going to call async def receiver, and we'll pass in the stream, the sender list, and the username. So what I'm going to do is move this while true block into that task, just to make it a little bit cleaner. So while true, while new line's not in current data, we receive some data and then we send it off. So I'll just get rid of that while true, so I'll stop complaining about my syntax. And we need to also define current data equals nothing. Then we split out the current data, print the message, and send it off. Just not sure why this is being unindented amount does not match previous indent. Oh, and we also want to put this in a while true block so that it basically runs forever. So we'll define our current data as empty. We'll receive some message, and then we'll send off the message to everyone in the sender list. Let's also move the starting of our sender, and we'll also do nursery.startSoon receiver. Give it the stream, give it the sender list, and also give it the username. So that'll kick off our sender and our receiver. They can run individually. And what happens is when either of these tasks causes an exception, the exception will propagate up. So it will propagate to here, and then it'll propagate up from this, and it'll propagate up to the nursery, and then every task in the nursery gets killed when an exception hits the nursery. So one thing that you might notice here is that now we're creating a nursery which all of our streams, all of our connections live inside the same nursery. So this is probably not actually something we want. So let's comment out our nursery here and not pass it in anymore. And let's actually make the nursery inside of our task. So we'll say async with trio.openNursery as connection nursery, and then we'll do all of our work inside that. Now we're not getting past that in, so we may need to also start these on the connection nursery, of course. Cool. So we've got now all these tasks running inside this connection nursery. So if an exception occurs inside one of these two, it will propagate up and it'll make sure that if the sender crashes, the connection nursery gets killed and therefore the receiver that's associated with it also crashes. Now we also want to catch that exception and prevent it from killing our whole server. So let's put this whole lot in a try block and say except exception as E. And for now, let's just print error occurred E. And so we'll just print out the message that comes from that exception. But we will not propagate the exception further. So now we'll catch that exception and prevent it from going any further. Okay, let's give that a try. So I'll say here Python server. So start the server. let's start our test client, and we'll say client 1. And then here I'm just going to interactively connect and say J. I'll say hello. And then I'll say bye. So you can see, the hello and the bye have come through. And now I will disconnect. And you can see that we've got error occurred up here. Socket connection error, broken pipe. But it didn't crash the server. So the exception got to here, error occurred, broken pipe, but we're still up and running. Now there is actually another bug that we've just introduced, which we need to have a look at. And so what is that bug? Well, you can see that this client's now not getting any data. And if I connect up here and say, what's your name? Jay, hi there Jay. And then I say, hello all. That message comes through. But eventually, all the sending of data has also frozen up now. So what's going on here? We're now both frozen. This guy's not receiving any data. This guy's not receiving any data. Well, let's have a quick look at what's going on. Okay, so what's actually happening here is that whenever we receive a message, we loop through all the senders in the sender list and try and send a message to them. And when we call that send channel .send, the sender task for that connection will receive the message, and then it will try and send off that message. Now that errors and we get an exception, but this loop, this guy is still waiting to send the message off to the sender list. So what we actually need to do is every time a connection breaks, we need to remove it from the sender list. So how can we remove it from the sender list? Well, one thing that we can do is we can actually maybe make the sender list a little bit more obvious what's going on. So here what we can use is a Python functionality called data classes. So from data classes, we'll import data class. And what this lets us do is say at data class, and we can define a data class that contains attributes of an object in a really nice manner. So what I say here is I say class, and we'll call it user connection. And then inside we can define a few attributes. So we will say the user connection username, and I can say here :str to show that this username is a string. I won't say what the value is because we need to define the username as we go. And then what else can we do here? Well, we can say that the send channel is going to be a trio.send memory send channel. There we go. So when you create a user connection, you have to give it a username and a send channel. So this allows us to, when we start up, we get our send channel, and instead of appending it to the list here, what we'll do is we'll first figure out what the username is. So once we've got the username and we've said hello to the user, so this block here is to get username. Then we now want to create this user connection. So we'll say con equals user connection, username equals, username equals the username that we just got. Send channel equals, and we'll give it our send channel up here. Okay, so now we have a user connection, and we'll append that to our sender list. So when we start up, we append our user to the list. But what happens if we have an exception? We need to actually remove ourselves from the sender list as well. So to do that, we may actually want to put another try block here potentially. So this is all after we have added ourselves to the sender list, and then we can say except, and any exception that occurs, we'll have to say remove ourself from the sender list, and then we can re-raise the exception. So you can just say raise inside an except block to re-raise the exception that we received. Now, one thing you'll notice here is that in the sender list, it's not actually very easy to find our connection anymore. So we may actually not want to use a list here. We might instead want to look at using a dictionary. So where we build it, let's, instead of a senders equals a list, let's say senders equals a dictionary. So we'll just make it an empty dictionary, and let's call it sender dict instead of sender list. And I'll just change the value here, dict as well. Okay, so what are we going to use then with our dictionary? Well, what we can do here is we can say that the sender dict and put the username here as the key, and then give the connection there. So instead of appending it to the list, we actually have a dictionary where we can pull out options, items by the username. And that means that when we want to remove the user from the list, all we can do is we can say senderdict.pop. So pop will remove an item from the dictionary and just give it our username. And then that is no longer going to be in the sender dict. So we do some work, we catch any exceptions, remove ourselves from the sender dict so that no longer people are trying to send to us, and then we re-raise the exception and carry on. Okay, so moving on, what have we got now? We don't need that anymore. Let's give this a try. There's almost certainly going to be at least one bug here, but let's give it a shot. Okay, so error sender list is not defined. It's because I'm passing through the wrong value here. Okay, sender dict, and this guy also wants to use a sender dict. Actually, and we need to handle it differently here. So instead of for sender channel in the sender list, we actually want to say for underscore. Now, underscore in Python generally indicates that you're defining a variable you don't intend to use, because what I'm going to do is say with our sender list, instead we'll use sender dict, and I'll say items. So items returns to us two values for every item. One is the key and one is the value. The key is going to be the username of each user that we're sending to. And then the value will be the connection of the other user con. And so we want to use the user connection because we need the send channel out of it, but we don't care about what the username is that we're sending to. So what we get out is one of these user connections, and then we've got there the attribute, the send channel. So we can say usercon dot send channel dot send. So that will pull out the send channel attribute from the user connection, and then it'll send off the message to it. Let's give that a shot, see if I've made any more mistakes. Okay, so we connect. Client 1 says, how are you? And he starts getting messages back from himself. So let's say Jay. And we start getting some messages through from the test client. And I can say, hi, hello, test. Okay, so those messages are coming through. Now let's disconnect and reconnect as another user. And you can see those messages are coming through, and I'll disconnect again, and we'll just try this a few times, and I'll say I'm Bob this time, Bob. Okay, and you can see now these messages are coming through more consistently. Although, this one does seem to have frozen again, so I wonder what's actually going on there. So I've thought a little about what might be occurring here, and I suspect that what's going on is that once one of the connections has crashed, we're going to end up with this error occurred, and this starts cleaning up the item from the sender dictionary. But if one of these receivers is already waiting to send a message, even though the user's been removed from the dictionary, we still are stuck here waiting for it. So what we might actually want to do here is actually do a new, introduce a new functionality from Trio, which is this move on after. So what I can say is trio.moveOnAfter, and I'll say 3. So we want to always wait a maximum of 3 seconds to send one of these messages off. I believe I say, sorry, with trio.moveOnAfter, await usercon.send channel. And we can actually here say as cancel scope. So trio.moveOnAfter returns us a cancel scope. So then it tries this task for whatever number of seconds you give here. If that fails, then it carries on. It doesn't raise an exception, but you can use the cancel scope if you want, and say if cancel scope dot, I believe it was cancelled. Let me just quickly check in the documentation. Okay, so I've opened up the Trio documentation, and in the Trio documentation, it's in the core functionality section under cancellation and timeouts. So this is where you can find the details of those cancel scopes. So they've got a bunch of different information there. And you can say with trio.moveOnAfter as cancel scope, perform a sleep for 10 seconds. And this one, however, is going to cancel the task after 5 seconds. So you can see then you get this cancel scope dot cancelled caught. So this is what we want to use, and that will print out true. So we can say here if cancel scope dot cancelled caught, and we can print here. In fact, we can even say let's capture the username that we're sending to as well now. So what I'm going to say is remote username, as in this is the other username that we're sending to. If we get a cancelled caught, let's print failed sending message to remote username. And so we'll print out an error when we get one of these failed sends. Let's give that a shot. Okay, so I'll start up the server. We get these connection coming in, and our test client is up and running here. I'll start this one up again, and I'll say Bob, hi from Bob, testing, blah, and then I'll now disconnect. And then this time I'll say J, and I'll say hello. Cool, so we got an error here. So, the socket connection broken pipe. And so you can see now we also get this message printed. So, failed sending message to Bob, and it's actually put in the byte string indicator because the username's a byte string. But we are carrying on down here, receiving and sending messages. And you can see if I send a message now, it does come through to the test client 1. And if I connect up again, and this time I say my name is Robert, and start sending some messages, you can see that comes through as well. We actually get an error here, which is interesting. So this one, we get an error occurred, dictionary changed size during iteration. And you can see actually that our test client was disconnected and then reconnected. So what's going on here? Well, when you're using a dictionary in Python, you're not allowed to remove or add items to the dictionary, or from the dictionary, obviously, while you're iterating through it. So this can occur if we are currently waiting for this move on after 3. If in another task, so we receive some data, then we start looping through this dictionary, and we say, okay, we're stuck here waiting. We're going to move on after 3 seconds, and then we sort of try and send the message, and then this task pauses. Meanwhile, another one of these tasks starts running, and it receives its exception and removes itself from the dictionary. Now, when this task gets resumed, we then catch an error here. We actually get an error, which is dictionary change size during iteration. So how might we address this? Well, there's a few ways to deal with this. One is to basically fully populate a local list before starting to send each message. So we could do something like remote users equals list. So I'm calling the list function, and I'll give it senderdict.items. So this remote users will now contain a dictionary of the username and the user connections. And then we can say remote users. So now that we have these remote users, and the important thing here is that it's a local copy, it's a local list, and we're no longer referring in this loop while we're doing our waiting, we're no longer referring to the original dictionary, and that's why this can work. Now, just to make sure that there's no bugs here, what I might do is I might just check that this starts up and runs correctly. So let me start up just a second version of the test client here, client 2, and we'll let these 2 test clients keep running. Cool, so client 1, client 2, they're sending messages back and forth to each other. And now let's kill off one of these test clients and reconnect it. So we get a socket connection broken, error reset by peer, and I'll just do this a few times just to basically force it to definitely end up hitting this error at least once. So, we can see a few errors occurring. So different socket connections are broken. We failed to send a message to one of the clients, but we haven't got this dictionary change size while iterating. And the reason is that we're no longer in the iteration referring to the dictionary. Now, this is one way to address the problem, but it's not the only way. And we can have a look at another way that we could address the problem. So another way we could do it is to actually pass in to our receiving task the connection nursery. So when you're looking at asynchronous code like this, the only time that other code can run is wherever you see this await keyword. So whenever you say await, what that means is pause the execution of the function we're in and allow something else to run. But if while we're iterating through our senderdict, and let's put the senderdict back the way it was. So we'll iterate directly through the sender dictionary again. While we're iterating through this, we do call an await. So when we call an await, our code is going to be paused here, and another piece of code may run. But if we don't do any awaiting inside of this, then we can actually instead, then we can make sure that this senderdict will never change size while we're iterating through it. So how might we do this? Well, one way we could do it is to define a new function, async_def, send message, and what you pass into this senderdict, this send message is the message you want to send and the send channel you want to send it to. So what we're doing is basically the same as this line. Okay, so we'll pass in the send channel, and we'll pass in the message. And basically we're going to duplicate the code that we're running up here. So we'll say with trio.moveOnAfter, we'll say maximum wait of 3 seconds as cancel scope. And here we will await the send channel dot send message if cancel scope dot cancel court, cancel court, like that. Then we'll print our failed sending message to remote username. And I might actually, so that we don't have to pass in the username here, what I'll just say is failed sending message, and we'll just print out the message that we were going to send there. Just that way we don't have even more arguments on here. So currently we've got this in an async def, and what we could actually do here is await send message. We give it the send channel that we want to send to, so that's going to be our usercon.send channel, and the message that we want to send. So that's going to be this message here. And now we don't need this code here because it's in that function. But what you'll immediately see here is that we haven't actually solved the problem. We've still got an await here, so we can still be paused while this sender dict is while we're iterating through this sender dictionary. And if we get paused, the dictionary might be changed, and therefore we may actually run into that error where we are trying to iterate through a dictionary that has changed size. So how can we do this without calling an await? Well, if we pass in the connection nursery here, which is something that we've already started writing, we now need to receive the nursery here, so I'm just going to call it nursery. Instead of calling await, we can actually say nursery.startSoon, and now we can say the function that we want to start. So we'll start send message, and we will pass it our 2 arguments. And just to make this a bit clearer what the arguments we're passing in, I'm going to do this on sort of 3 lines. So first one is the function we want to call, second one is the send channel we want to send to, and then the third argument is the actual message. So it's username plus the colon space, and then the message, and then a new line appended on the end. Okay, and now we don't need to use await. So what we're actually doing is, and I'll just change that back to an underscore because we're not using it anymore. So what we do now is we actually iterate through the dictionary. So we get out every user connection, and we schedule the starting of a message. We say in the nursery that we're running in, we want you to do this soon. So soon, please send the message to this user. Here's the message we want to send. But then we immediately carry on iterating. And so we'll complete the iteration and move on from that code before any of these send messages actually start being called. So this gives us 2 benefits. One is we fix our bug, which is our dictionary changing size while we're iterating through it. But the second thing that we've actually solved here is just the slowness of sending out the messages. Because before we would start sending each message in the loop, wait up to 3 seconds for it to send, and then move on to the next message. And you can, doing some maths, let's say we had 50 other clients connected, 50. And we wait up to 3 seconds for each of those, and let's say that they're connected but they're slow, so the messages do send through successfully, but they take 2 seconds to send. So it could take up to 100 seconds for each message to send. But these messages, they only take 2 seconds to send. Surely we can send them through all immediately and then wait 2 seconds. And the operating system knows how to send data on many different sockets all at once. So by actually scheduling them, we can send the messages faster because we say, prepare these functions, all 50 of them, if there was 50 items in the sender dictionary. And then once we complete, we move through our loop again. So we come back up to this start of the true, and we say, oh, is there a new line in the current data? And then we hit an await here. So then we actually suspend this function, the receiver function, and our nursery will say, okay, who's next? We need to run the next function that's waiting. And then it goes down and it says, okay, we need to send a message. There's a send message waiting in the nursery. And so it starts up, it gets to this await send channel, and then this function suspends, sending to that user. Now, the operating system will keep sending bytes off over the network while this is suspended. But the nursery suspends this function from Python's perspective, and then it moves on and goes, okay, what's the next function in the nursery to call? And there's another send message, but to a different send channel. And so it starts that one, and there's another one, and it starts that one, and it starts up all 50 of them. And as you can imagine, when you're like on a local computer, starting up 50 tasks takes a fraction of a second, microseconds. But then we can just wait for the network to slowly send off a few bytes each to each connected user. And they each take 2 seconds, and the total time to send all these messages might be somewhere around 3 or 4 seconds with a little bit of contention on our network. But assuming that the server has a really fast network and all the clients have a really slow network, we'll complete much nearer the maximum time to send to one user rather than the time to send to every user. So I hope that makes sense. And let's just test this before I've declared how it's going to work, but we haven't actually tested it up. So we've disconnected our 2 test clients here. And what I might do is I might just start up a new test client again. So let's do that, test client, and I'll say client 3. And I'll also then interactively join the session here. Cool, so let's start up the server and just make sure that we don't immediately hit an error, which we have. So what have we got here? Cancel scope object has no attribute cancel court. I believe that's because I actually need to say cancelled court. So let's give that a shot. Okay, so our test clients are all connecting up, and we've got messages coming through. What I might do just to make those a bit nicer is just quickly search for some lorem ipsum text. Oh, no, we want just words. Sentences, here we go. And I'm going to add some extra messages here because currently we only have like 3 messages coming through, which is a bit sad. So let's chuck some more in there. Okay, so we got a bunch more messages now. We'll kill and restart these guys. And we've, got some errors occurring up here. And it still seems to be working as expected. And if we now start up our connection here, I say J, I should start receiving messages from the other clients. And I can say hi all, and you can see that my message makes it through to the other clients as well. So we're still working, it's still functional as it was before. Now, we haven't solved the problem of users' messages being sent back to themselves, but this is probably enough content for one video, so I'll stop it there and we'll look at some more bugs in a future video.